Hello there, class. We are going to talk today about set 45, difference of two squares. So we've seen this before where we have a squared minus b squared, so two perfect squares that have been subtracted and they're equal to 0. Then we would take each of our sets of parentheses here, so a minus b, we set equal to 0. We take our other one, a plus b equal to 0. Then we solve for a or b, so here we would add b to both sides. And we get a equals b. Over here we would subtract b to both sides. And we get a equals negative b. So those two are very nice and simple and easy, but we're not always going to see difference of perfect squares now. So here, this problem could have started easily like this. Okay, 17 is not a perfect square, so we can't just split it into a plus b and a minus b. So we are going to solve these ones a little bit different. I would go ahead first, and this one was adding the 17 to both sides, and that's how we got this. Now we need to get rid of the squared. Well, opposite of squaring something is taking the square root of it, just like addition, subtraction are opposite, and multiplication and division are opposite. So I'm going to take the square root on both sides. So the square and the square root cancel, and I get x. But I now, on the other side, I don't just get a square root of 17, I get a positive and a negative square root of 17. And the reason why that happens is, let's have a side note here. If I take 2 squared, I'm going to get 4. But I can also take negative 2 squared and get 4. So both of them give me a positive 4. So I need to keep in mind that the square root could give me back a negative and a positive. So that's why we have the plus and minus sign. And that's actually where we would leave this answer at. So not too difficult with simple ones like that. Let's look at this one. Here, it's a little bit different. Now we have a binomial squared equals 17. But we're going to follow the same step. We're going to take the square root on both sides because I have the squared term here. Okay, so now I get 8 minus x, x minus 8 on this side equals positive and negative square root of 17. Now I want to get x by itself. So to do that, I'm going to go ahead and add 8 to both sides. So I get x equals, then we're going to have 8 plus or minus the square root of 17. And we're going to leave our answer right like that. We don't have to go any further, so that's really nice about this type of problem. Okay, this works best when we get problems where it's something squared right away. If it wasn't like that, we'd have to do some addition and subtraction first. All right, so this problem's set up just like the last one, where it's got something in its parentheses squared. So we start off by taking the square root on both sides. That will cancel, and we're left with x plus 1/2. Notice we aren't doing anything with the stuff in the parentheses. Equals, we have our positive and negative square root of 15. I want to get x by itself, so I want to move that 1/2 by subtracting it. So that cancels. So x equals negative 1/2 plus or minus the square root of 15. And I don't have to go any further. We're going to leave it just like that. All right, let's give this next problem a try. We are going to, again, follow the same thing. We're going to take the square root on both sides, just like this. Those will cancel. X minus 4 equals, you guessed it, plus or minus square root of 5. We want to get the x by itself, so we want to get rid of 4. So I'm going to add 4 to both sides. X equals 4 plus or minus the square root of 5. We don't have to go any further. We leave our problem just like that. All right, one more. Last one. Short and sweet today, huh? Square root on both sides. Those will cancel. M minus 3 over 4 equals, yep, plus or minus square root of 2. We want to get my m by itself, so I'm going to add 3/4. Add 3/4. So we get m equals 3/4 plus or minus the square root of 2. We leave our answer as such, and there we go. So Very simple. If we have something that's squared by itself, we're going to take the square root on both sides, and then we isolate the variable. All right, make sure you ask questions on this set if you have any. See you guys later.